So we already touched on what product means, but if you needed a reminder, then maybe star highlight that product is the answer to a multiplication problem. Floating, so I'm doing that, but product is the answer to a multiplication problem. Integers, what does it mean to be an integer? Or if it says your answer needs to be an integer, what does it exclude? Good. So integers exclude decimals. So not a decimal is what it means by integer. So if it says to round your answer to the nearest integer, basically nearest whole number. Integers can be positive or negative, they just can't be decimals. So they gave you an example, 2 and -6, when you multiply them, you get -12. We want other pairs of integers, so non-decimals, that also multiply to -12. So table 3, can you give me another pair that multiplies to -12?
3.
All right. Good. Table 4, can you give me another pair? 1 times -12. Table 5. Okay. Good. Table 6. Any others? -3 times 4. Table 7. Any others? And table 8. Any others? Okay, good. They already gave us that one, but I'll go ahead and list it anyway. These are all the pairs that multiply to -12, all the possible combinations. A common one that they'll try to make you find on a test is like 24, because there's lots of numbers that multiply to 24. But for -12, these are all the possible combinations. Anyway, from this list all the pairs that have a positive sum. So what does sum deal with? Okay, so either in your head or with the calculator, I don't care which one you do. Tell me a pair that when you add them, you have a positive sum. So table 9, can you tell me which of these would give me a positive sum? So like, would 3 plus a -4 be a positive number? And 9 will come back to you. Jack?
2 and 6.
Which one? Because 2 times 6, they're both positive. So which one are you talking about? The -2 plus 6 or -6? Right. Okay, good. -2 plus 6. I'm writing them still as factors, but -2 plus 6 gives me a +4. So that's what we mean by a positive sum. When I add them, which ones give me a positive sum? So table 9, can you give me another one from the list that would also have a positive sum? -1 times 12, that would give me an 11 when I add them. Table 1, any others? Any others from this list that when I add, I get a positive?
Three to 4.
Okay, I don't see a +3 and a
Oh,
positive.
-3.
Okay. Class, are there any others? That when I add them, I get a positive sum? Yeah,
-1, 12.
okay, we have them. All right, any others? Okay, so then the next question is of the pairs of factors you found, so like my list in blue, which ones give me a negative sum? So table 2, sorry, no, which ones would give me a negative sum? Good, negative 12 and 1, table 3 and the others. That would give me a negative sum when I add them. Good. Table 4 and the others. Okay, good, and that exhausts the list, because the others we already said give a positive sum. All right, so not bad, way better than the start of my day. This went by pretty easy. Any questions on how we got any of this? So this warm-up is intended to review your integer rules, because the goal is still to rewrite quadratics in factored form, but you need a good understanding of like what happens when you multiply to positive, what happens when you multiply to negative, what happens when you multiply opposite signs. All right, in this one, since our answer for the multiplication problem was negative, we needed to have one of the numbers be negative. Okay, so refresh that in your memory. When you have an odd number of negative signs multiplied together, your answer is negative. So odd number of negative signs multiplied gives a negative answer. If you already knew that, then great. Otherwise, you can use a calculator, but the more fluent you are in these rules, then the better off you'll be in this unit. Then when it comes to adding numbers with opposite signs, what's that integer rule? Like, how do you know that these give you a positive when we add them? So think about what the rule is for that. When adding numbers with opposite signs, we do what? Like, what is negative 2 plus 6? It is 4. It's not 8, even though like 2 plus 6 is 8. So we're actually not like necessarily adding them. We are subtracting them, right? Like their absolute values, like 6 minus 2 is 4. But how do we know what sign we keep? Whichever one is larger. So when adding with opposite signs, we really are subtracting and keep the sign of the larger number. And when we say larger, we kind of mean like obviously down here, negative 12 is actually smaller than 1, but we mean like ignore the negative. Which number is bigger? You keep the sign of the bigger number. But really, we are subtracting. So like, what's negative 1 plus 12? A positive 11. Really, we just did 12 minus 1, but then we keep the sign of the bigger number, which is the 12. What is negative 3 plus 4? So really, we did 4 minus 3, but we keep the sign of the bigger number. So that's why it's a positive 1. Down here, same thing. What's negative 12 plus 1? So we did still 12 minus 1, but we keep the sign of the bigger number. Negative 6 plus 2 is, so we did 6 minus 2, but we keep the sign of the bigger number. Does that make sense? Okay. When in doubt, use your calculator, but the more fluent you are, the better you'll find the numbers that should be like your factor form. Any questions on that? Yes. 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 Okay. That's good. Everyone else? So the goal today is to write some more expressions in factor form. This is a continuation of yesterday's lesson. They really ease you into it. So if at any point you're confused, please ask. But we are still continuing to go from standard to factor form. When I talk about factor form, what should my answer look like? Or what should it have in my answer? Table 7, can you tell me? What do our factor forms look like? Or can you give me an example? Guys, think about it. Table 8, can you tell me what my standard form of quadratics is? Like, how do I know that it's in standard form? Okay, so the parentheses goes with factor form, actually. So standard form looks like what? Okay, perfect. Those other numbers we usually will denote with A, B, and C. That will be especially important later in this unit. A is always in front of the x squared, B is always in front of the x, and C is always a constant. So even if I write it in a different order, say like this, is an example of something in standard form. I know that A is in front of the x squared, B is in front of the x term, C is always the single number, the constant. Okay, so table 7, what does factor form look like? Or give me an example. What should factor form have in them? Parentheses. Anything else?
Like 1 plus x, and then like 2 plus x.
Okay, that works. I think normally we've been looking at it where the x is first, but this is still considered factor form. Good. The numbers depend on what it has to be to multiply to C, but add to B. That's what we discovered yesterday. And we're gonna continue to do that today. So good, just making sure we know what's going on. I stand up here every day, so you should at least be able to tell me the difference between factored and standard form, if that's our whole goal, is to go from standard to factored. I record every day. It's always linked in the slides. You can work ahead sometimes. The video's there from last year. Notes are there. And the practice is there usually for the whole week. You'll be after it. Today's practice will be lesson 7. We might even have some time in class to work on it. Just depends. Puzzle piece, not puzzle piece. You will have your first quiz for this unit on Friday over what we've learned so far. So just make sure that your notes are up to date and you understand them. I appreciate you taking notes, but it really gotta do the learning too. So please, hopefully you're not just blindly copying them. Any questions on this one? Okay. So then the front side of your paper, this next activity. First, you're gonna look at this expression, which is in standard form or factor form. Standard form, good, we just talked about that. So yes, it's in that form, ax squared plus bx plus c. Yesterday, we learned that our factor form, when we find that, we are multiplying to get our constant. And we are adding to get the number that goes in front of the x term. And today we are just dealing with when a is 1, that's why they didn't write an a there. It's not written as a soon to be 1. The process is a little bit different when a is not. But anyway, First, we're gonna look at pairs of factors of 100. What do we do with factors? We multiply with factors. So when I say I want factors of 100, I want pairs of numbers that multiply to 100. And just like in the warm-up, you saw that there's lots of combinations. You're gonna sort those factors by whether or not they would give a positive value of B. So when you add them, would it be positive? Or would it give you a negative value of B? Use as many rows as you need, but that's what you're doing first. Find all the pairs that multiply to 100, sort them in the tables by, do they add to give a positive or a negative? Do that with your tables. I'll give you 3 minutes. It's a long time, but that's gonna be 3 minutes. Table 5, can you give me a pair of numbers that multiplies to 100? 2 and 50, and should I put that in this table or this table? Because when I add them, I get what? 52, so that's how you're sorting it. There's lots of numbers that multiply to a positive 100. But the ones that when you add them would give a positive value of B, that's what goes here, okay? So table 6, what are some other numbers that multiply to 100? 4 and 25. And should I put that in this table or that table? 4 times 25 is 100. When I add them, it'll give me 29. So that's why we put it in this table, because if we add, we get a positive. Table 7, other numbers that multiply to 100. Sorry, one more time. 10 and 10, so I put it in this table or that table? Okay. And what would be the value for B when I add them? 20, right? Is that what you said? Okay, 10 plus 10 is good. Positive, that's why we're putting it over here. Table 8, any others that multiply to 100? Eight other numbers that multiply to 100? 101. Okay, so I put it in this table or this other table? This one. And when I add them, what do I get? 101. So that's why it goes in this table. Table 9, other numbers that multiply to 100. 25. 20 and 5, should it go here or in this table? Okay. When I add them, what do I get? Okay. Does anyone think that there are any other numbers that need to go in this first table? Or have we found all the ones that give positive values when we add them? Okay. So then table 1, give me a pair that would go in this table. Negative 20 and positive 5? Do those multiply to a positive 100?
Oh, wait, no, negative 20 and then negative 5.
Okay, and then when I add them, I get. Okay, good. So we still want it to multiply to a positive 100. And since I have 2 negatives, that would multiply to a positive. And yeah, when I add them, this is what I get. So if you put negative 15, just fix that. Make sure these are both negative. Table 2, can you give me another pair that should go in this table? Good, and when I add them, I get. Good. Table 3. And when I add them, I get. And so what are we noticing? Anything? What else can go in this table? Early? So it's mirroring this table. Except for that, all of the answers are now negative. Okay, so when I multiply a positive, I get a positive, and when I add them, I get positive. When I multiply two negatives, I get a positive when I multiply, but when I add them, I get all negatives, and it's almost exactly the same as this table. Table 4, what's the other one that's missing from here? And when we add them, we get. And that's all of them. Those are all the possible combinations that can multiply to a 100 and add to either a positive or negative. So this is really close to something that'll be on your constructed response. It'll say, given this, what could B be, or what could the factor form be that it gives a positive value for B, and so on. So good. Any questions on multiplying? Most of this integers is what we're doing. Okay. So now we're gonna see what happens when it's a negative 100 that we're multiplying. So we're gonna look for factors of a negative 100. And you're gonna sort them now based on whether the value of B is positive, negative, or 0. You may not use necessarily all the rows on your each table, but think of numbers that now multiply to a negative 100 and sort them based on that. So you know it's pretty good. All right, table 9, give me a pair of factors that multiplies to negative 100. Any two numbers that multiply to negative 100. Negative 25 and negative 4, is that what you said? So that would multiply to give me a positive 100, so how can I adjust that? To make it give me a negative when I multiply? All right, class, what's the rule for multiplying negatives? Like, how do you know if your answer is gonna be positive or negative? If it's two negatives multiplied together, you get a positive. So if I just want my answer to be negative, I need just one negative sign. Does it matter which one it's on? Maybe sometimes. For this activity, not really. It could be on the 25 or the 4. So let's try just negative 25 times 4. That multiplies to give me negative 100. What table should it go in? If these are my two factors, it should go in this one, where when we add them, we get a negative value for B. What's negative 25 plus 4? Negative 21. Does that make sense? Are we getting it now, maybe? Okay, so table 9, try again. Give me another pair of numbers that multiplies to negative 100. Wait, table 9 would be. What was that? 20 times negative 5 does give me negative 100 when I multiply. What table do I need to put that pair in? the first table, because when I add them, I get a positive. What do I get when I add them? 15. Okay, table one, your turn. Give me another pair that multiplies to negative 100. And what table should that go in? Okay, good. Negative 50 times a positive 2 gives me negative 100. When I add them, it gives me negative 48. So that's why it goes here. Table 2, give me another pair. Negative 2 times 50. What table should that go in? Good. When I add them, I get, so you see a pattern. Maybe those of you that are stuck, like maybe this can help you find other combinations. Table 30, give me another pair. Either one. Okay, so for this one, negative 20 times positive 5, and when I add them, I get, good. Table 4, another pair. And which table should that go in? Negative 1 times 100, when I add them, I get table 5, another one. Negative 1, negative 4 times 25, what table should that go in? And what do I get when I add this? Okay, now I'm gonna ask that entire table because I feel like Justin's not wearing the most blue color, so we'll ask all of you now. Jack, give me another pair.
For, positive one, million,
And what table should that go in?
negative 5.
Good. When I add them, class, I get negative 99. Thanks, class. Liliana, another pair. And what table should that go in? Good. Because when I do add them, I do get a 0. So I actually wouldn't have an x term at all, like 0 times x would be 0. So my value b would be 0. Class, are there any others at all that we miss? I think that covers it. So yeah, good job. Now apply that to the actual thing you'll probably see on your test, because they probably won't ask what multiplies to this and adds to this. But you need to know that that's the question you need to ask yourself when you are factoring from the standard form. So now you have 4 different expressions in standard form. You're gonna write them in their equivalent factor form. Yesterday, I showed you things like the diamond method. You could also do like the box diagram if that one helps you. But notice that the C value is all versions of 100. And the B value is all numbers we've seen today. So maybe use your tables to help you if you get stuck. And use this as a refresher. C was always a product. B was always a sum. If I'm asking for the factored form, my answer should look something like this. With the numbers and the signs corresponding to what it has to be to make it work. Okay, give you, I don't know how long you need. 3 minutes again. If you finish that, I'll send you the pull down where it gives you like the signs of the numbers to fill in. Six. What should be my factored form if this is my standard form? So, good, that is the right answer, if I remember correctly, otherwise I'll show you how I would like to find the answer. I prefer the diamond method, which I showed you yesterday. The way that you would set it up, A times C goes on the top, B goes on the bottom, the A, B, and C come from AX squared and BX to C. In this lesson, A is 1. You'll see what happens when A is not 1 later on. But so you always do A times C on top though, so 1 times 100 is 100. B is negative 25. And it sets it up to be kind of like a puzzle where you're multiplying to the top and adding to the bottom. So they said negative 20 and negative 5 do that. Do you guys agree? All right, looks good to me. These multiply to 100, but add to negative 25. So that is my factor form. Table 7, give me the next one. Sorry, one more time. Okay. Do these multiply to give me a negative 100? They do add to give me a positive 15. So let's set up the diamond class. If I use the diamond method, what number has to go on top for this one? And what number on the bottom? Good, so always keep the sign that's in front of each term. So this is a negative 100. So two numbers that multiply to this but add to this are what class? Maybe look back at your tables when you did all that. Which one gives me a positive 15 when I add? Positive 20 times a negative 5 is that. It works for the entire diamond, not just half of it. So fix that. It should be plus 20 and minus 5. Written in factor form like this. Good. Any questions? All right, I also mentioned you could do a box diagram if you want. Personally, my opinion, I think those are kind of hard. I've also seen some people just like almost out of thin air pull out the factors from their head, knowing it and just writing it down. Highly recommend this diamond method. Simmer down, we're not done. We're still going over a lot of it. There's still a lot of time in class. Table 8. What goes here? Like if I want to use the diamond method, how do I set it up? What goes on top? And what goes on the bottom? Oh, we're doing B. Oh, good. Did you guys get an answer for this one? Okay, so I'm guessing this is what you mean. Let's see if that works. So yeah, it does multiply to negative 100, does add to a negative 50. So in factor form, it looks like this, with the signs corresponding to what it had to be to make it work in that kind of method. All right, table 9, do we have the answer for this one? Okay, then help me set up the diamond. What would need to go on top? And what would need to go on the bottom? What are two numbers that multiply to negative 100 that add to a positive 99? Okay, good. So it has to be x minus 1, x plus 100. And yes, you could like switch the order. You could do the x plus 100 first, the x minus 1 second. It has to, when you multiply, and give you that. If you haven't tried the cool down yet, highly recommend. That's how you really like know you understood the lesson. You're filling in the little squares with the sign that it should be. And then you're filling in the blanks with the numbers that it should be. I'll project that answer in a few minutes. when and if you finish early, work on your practice, with lesson 7 today.
These are great.
But they are asking you to fill in the blanks. So for some of them, you're filling in the signs. For others, you are filling in the numbers and the signs. So for the first one, if this is my factored form, remember that our standard form, at least when A is 1, it'll be different when A is not 1. The constant is always the product of these two numbers from your factored form. I don't know how to describe those two numbers, I don't have a special name for them. And B is always your sum of those two numbers. So what is 1 times negative 17? One times negative 17. So then this would be negative right here. What's 1 plus negative 17? Negative 16, so there should be minus right there. Your integer rule. Now, what they did here was switch the signs. What's negative 1 times 17? Table 9, can you tell me negative 1 times 17? Negative 17. Table 1, what about negative 1 plus 17? And it's positive, so we put plus there. Now down here, when we're going from standard to factor, that's where I like to set up the diamond. I think it makes it easier. The way that I would set this up is negative 28 on top, positive 3 on the bottom. I need two numbers that multiply to negative 28 that add to 3. So don't tell me the answer yet. Usually what I'll go through in my head, if I can't easily think of it, is I'll just like start at 1. So I know 1 times 28 would give me 28 in some form. 2, it's divisible by 2. 2 times 14 gives me 28. Not divisible by 3, is divisible by 4. 4 times what gives me 28? 11. 7. Not divisible by 5, not divisible by 6. You could even try that out in your calculator if it's giving you decimals. Can't use that number, we only want integers. And then once I get to 7, I'm like, okay, now the numbers are repeating. These are all the possible combinations. And since it multiplies to a negative, one of the numbers must be negative. Which one could possibly give me a 3 when I subtract? Good. And the reason I said subtract is because when they're opposite signs, really you're subtracting. Which one needs to have the negative? The 4. If it's adding to give me a positive, the negative needs to go on the 4, on the smaller of the two numbers. So then the order does matter for this one. The 7 has to go there, 4 has to go there. I don't need to write negative 4, because they already have the minus there, so don't do that. I have seen on tests where if it's negative, they'll have blanks like this. And if it's negative, they'll like want you to type in the negative, but if it's already there, you don't need to write the negative. Okay, next one. Set up your diamond. I would set it up. That's a great method to organize your work. Negative 28, negative 12 on the bottom. Here's my list of numbers that multiply to 28. Which ones could possibly give me a negative 12? Table 3, can you tell me? 2 and negative 14, yes. There's no way I could mess around with 1 and 28 to give me 12. Same with 4 and 7. It has to be these two. Since it multiplies to a negative, one of them has to be negative. Since it adds to a negative, it has to be the negative 14. So it has to work for the entire thing, like a puzzle. So then here, it doesn't really matter what order you do. But one of them has to be -14, the other one has to be +2. Good, any questions? That also works. Okay, so then that concludes the lesson. You have 2 minutes before you can pack up, so finish maybe another problem.